to evaluate this definite integral, we can ignore these limits of integration for some time, and we'll come back to that later, or we can keep working on these from the beginning. So I want to show you both methods here. So let's ignore 0 and 1. Then we have basically a indefinite integral of x plus 2 over root x squared plus 4x. It seems it's clear we cannot get rid of this fraction, so, and there is no quotient rule, so we have to make a u substitution. Okay, and look at the bottom, inside the root sign x squared plus 4x. What is the derivative of x squared plus 4x? That's 2x plus 4. We don't have 2x plus 4, but if we multiply by 2, then it becomes 2x plus 4. Okay, so let's let u be the x squared plus 4x. Then du will be, this derivative is 2x plus 4 with respect to x, and let's simplify. So du is, we can factor 2 out, 2x plus 2 dx, and we do have x plus 2 dx on the top, x plus 2 dx, and as 2 we can divide by 2, so divide by 2, so half du is x plus 2 dx. In this way we can convert this whole integral in terms of u. Then without these limits, this integral becomes, I'm writing I integral on the top x plus 2 dx, that's du over 2. So I want to write here du over 2, and we have 1 over root, this is our u, root u. Now this is well known indefinite integral. We can easily find its indefinite integral using the power rule. How? This 2 we can pull all the way outside, so 1/2 integral u raised to 1/2 on the bottom, take that to the top, so u raised to negative 1/2 du. Using power rule, it's like x and dx, so 1/2 u raised to negative 1/2 plus 1, positive 1/2, divided by positive 1/2 plus c, but we have to work with these limits, so I don't need plus c, and we need to back substitute the value of u. In fact, 1/2 on the top, 1/2 on the bottom, we can cancel, or if you move this 2, it goes to the top, so cancel. So we have square u raised to 1/2, same as square root of u, which is square root, 1 raised to 1/2 means square root of u. U is x squared plus 4x plus c, but we are working on, we need to work on these limits, so I don't want to put plus c. Now we need to evaluate from 0 to 1, so we said this definite indefinite I, and we want to go from 0 to 1, which is evaluate this integral at 1 minus evaluate this at the lower limit 0. So that's square root of, plug in 1 is squared 1 plus 4 times 1, 4, 1 plus 4, 5, that's the upper limit. Okay, so square root of 5 minus, plug in 0, 0 plus 0. Okay, and just 0, square root of 0 is 0, so square root of 5, that's the final answer. In fact, when we made this u substitution and changed this integral in terms of u, we could take care of the limits as well. So let me show you alternative way. So okay, we will have this same u substitution, same thing. So I'm going to start from here, and this second method is more useful later. Okay, the idea is same. So you want to make u-substitution, and we are trying to convert everything in terms of u, and these limits are for x. When x equals 0, what happens to u? So we need to find that. So when x, these limits are with respect to x. So when x equals 0, so we work on this substitution. So when x equals 0, u is equal to 0 plus 0, 0. And when x equals upper limit 1, u will be 1 is squared, 1 plus 4 times 1, 5. So it will be 5. Okay. Then the given definite integral, then the integral is, now we are converting everything in terms of u. So 0 to 1 in terms of u, 0 to 5. So 0 to 5. And as we have decided, this is 1 over root u. Okay, this is our u. And x plus 2 dx. X plus 2 dx is half du. Du over 2. Okay. This 2 we can pull all the way outside, 1/2. And now we have 0 to 5, square of u on the bottom, u raised to 1/2, but when we take to the top, negative 1/2, and du 1/2. Let's find the definite integral of un, like u n plus 1, negative half plus 1/2 divided by 1/2, and we have to go from 0 to 5. Since we converted these limits for u, we don't have to back substitute. Now we want to work on this one. This is 1/2 is independent of these limits. We can pull outside, and when we pull outside, that's on the bottom, top 1/2, bottom 1/2 cancel. Now u raised to 1/2, we need to evaluate the upper limit minus lower limit. So replace u by upper limit. So 5 raised to 1/2, that means square root of 5, minus 0 raised to 1/2, which is 0. So the final answer is root 5, which is same as earlier.